Hi, my name is José Berardo Cunha and this video is part of the series about mobile development architecture. Over several videos, we covered many different approaches for developing a mobile app. Now you have a proper understanding of the different philosophies they follow, as well as some nuances even between solutions the same tier. For example, cross-compiled apps can run as simple as native, have bridge, or even provide their own set of fundamental components. Now it's time to help people where to start. If you plan to become a mobile developer but have minimal or no background on any of those technologies presented, or even have no programming skills whatsoever, this presentation is for you. I hope you'll find that clarifying, so if you do have this impression, by the end of this video, you really think that I'm saving and respecting your time, please thumb this up, please share with your friends, that might be also helpful for someone else. There is nothing better than start with data. Although this is from a survey called the State of JavaScript, which brings up eventually little biased results, as it tends to valorize more web solutions due to their natural audience, I still think that's worth sharing anyway. You can find some potentially useful insights. For example, as per 2017, native apps are still the most popular approach. It has the highest proportion of people who have used and still believe they're gonna use in the future. React Native is also getting popular with high number of people willing to learn more about it. On the other hand, PhoneGap/Cordova have the highest rejection, with many people saying that no longer have plans to use them in the future, or have never used but anyway don't want to learn them. I believe Ionic inherits this rejection, but as a complete solution, on top of Cordova, it has its own public to balance the numbers, and attenuate this rejection in having a large number of people willing to learn and also happy using Ionic. NativeScript is clearly the last known solution. And finally, Electron. To be honest, I don't know what it is doing on this list. This graph shows how much developers are being paid per technology per annum. In my opinion, it shows a technical tie. I don't see much difference and feel like it might be interesting only for those who have no idea how much they should be paid for work in a mobile development area. Now this graph shows the most frequently remembered older technologies, and not surprisingly, PWAs are the highest one. On the other hand, what a great surprise seeing Wix running up so close. Xamarin has also good marks, and after a reasonable gap, Appcelerator, Titanium, Flutter and Fuse were also mentioned. Getting back to our main discussion, the development tiers, there are a couple of ways to build a solid knowledge on this. The first strategy might be bottom-up. This way, you start from one of the two main mobile platforms. If you are starting today, I'd recommend Kotlin, as it seems to be the future of Android native development. On the iOS side, I'd recommend Swift because it's already the present. You might be fine enough learning just one of them. There will be market for you anyway, and surely you'll find a lot to learn once you start digging into any of them. But I'm here to recommend you to become what I call mobile polyglot and raise considerably your chance to work. If you don't want to stop there, I'd recommend you to learn JavaScript/TypeScript, so you'll be able to attack cross-platform apps using web approaches, from web native app solutions all the way to the top. The lower you are, the more JavaScript and framework-related stuff you have to learn. The higher you are, on the other hand, the more knowledge you need in HTML for content and CSS for presentation. Do you know that's possible to write Kotlin and target iOS? There's a project called Kotlin Native, where you can compile your code directly to underlying architecture, and iOS platform is among them. I'm not sure if it's easy or even possible to have a single code base targeting both Android and iOS per project with Kotlin Native, but at least it's one single language to learn. So stay tuned, Kotlin Native might be in the next big wave on mobile development, but for now there's nothing guaranteed. You can also go all the way around, starting from web apps, where I recommend you to first learn HTML and CSS, even before coding. Only then learn JavaScript or TypeScript, and finally go deeper and deeper. You might feel comfortable only at the PWA level. As we discussed before, there you can work offline. You can count on handy web APIs like payments, authentication, or even lower level ones like generic sensor or WebVR. But once you decide to go below the browser, at the hybrid level, the native APIs will be your new friends. Even relying on Cordova or PhoneGap, or more recently Capacitor, you might find yourself not covered at some point if you don't know how native APIs work on the underlying platforms. Below the web view, it becomes more dramatic. I'm pretty sure that sooner than later, you'll find yourself aiming to learn native APIs and especially native components for a better understanding of what's going on. Hey, now things start to become less obvious. For those brave enough to put all the chips into something that's nothing more than a good promise, that's my opinion on April 2018, I'd recommend Flutter. Why? Well, cross-platform has its own set of components, which makes you more independent on native environment, reach both platforms without bridges, which is in theory more performant. So only time will tell, but good technologies normally pay off pretty generously the early birds. So it's up to you. But what about the web? There is officially no plan for making Flutter compile to web browsers. But I will share a talk from a guy from the Dart team that argues if you follow some standards, you can have your code decently shareable with Angular Dart. What is Angular Dart? Well, Dart is a language that also compiles down to JavaScript, so I'm not saying that's an easy path, but at least it seems possible. Okay, I hope the previous slides have helped you to find your own learning strategy. But to be honest, I'm skeptical that anyone can follow any of them and neither stay too much superficial across everything, nor stop moving on at some point for a deep dive into those universes. Let me explain that. As a consultant, working for a company that more than just outsourcing does advisory, I'm in a position of having to learn more than one mobile development architecture in a reasonable depth level. So if you don't want to be limited by one specific approach, I'd like to also have you covered in more efficient way. I'm not saying that's not a long path, but if you break it down into logical pieces, it might sound doable. The main motivation is efficiency. Have you ever realized if you want to learn a new language and you go through official docs, tutorials, books, online course, or whatever, it's hard to identify what parts to skip because you already know them. For instance, let's assume you've learned OOP. You understand what a class is, how to instantiate objects, and manage to get a decent knowledge about many object-oriented programming aspects. Okay, so learning another language, wherever you're sourcing your new skills from, they never know how familiar you are with the concepts. Sometimes it's hard to balance what to pay attention and what to just skim to don't waste much time. Experienced developers might find that easy, but I'm pretty sure that's very cumbersome for beginners. In your mobile developer learning highway, you'll find many similar new places. Languages are fairly similar. Devices always deal with pretty much same features like camera, GPS, sensors, limited local storage, offline work, and so on and so forth. I suggest you to take a path based on concepts and features instead of platforms and languages. It has worked for me and might work for you as well. First things first, you should master the three main languages at the moment: Kotlin, Swift, and TypeScript. Okay, we could say Java, but let's aim for the future, so Kotlin is apparently a better choice. I guess Swift is more consensual on iOS side. But what about TypeScript? The most popular web frameworks do not require that. So that's just my personal opinion. With TypeScript, you at the end will be doing JavaScript, and better leveraging the most recent ECMAScript standard. If you don't know, JavaScript is based on a set of standards called ECMAScript. With TypeScript, you'll be doing JavaScript, and better leveraging the most recent ECMAScript standard and being able to easily transpile to something readable by old browsers. The advantage is you will have a type-aware compiler keen to help you to avoid many mistakes unfortunately common on dynamically typed languages. Even if you don't intend to work for web, I'd still think it's important for the server side. Serverless approaches, for instance, Firebase Cloud Functions, a natural first choice to back mobile apps, and JavaScript is their most popular, sometimes unique option. And finally, what about Dart? Yep, at this stage just something worth mentioning, but I'd like to leave it up to you. Once you've made your first step, you should focus on the environments. At this stage, you might realize I prefer the bottom-up strategy. I kind of do. It really feels more natural to me. For every web API that you learn later on, you'll find a native counterpart, but the opposite is not necessarily true. Many web widgets mimic native components, so they might all sound familiar to you. And especially web-native solutions, like the popular React Native, are heavily dependent on native components, so knowing how they operate upfront is a huge differential. But just remember, concepts and features rather than platforms and languages. Divide your strategy in a sequence of learning concepts and features rather than platforms and languages. Again, I'd say the same about Flutter. It's currently in beta 2, so there's still a lot of hype on that, but this presentation wouldn't be complete taking it for granted. So that's why I decided to also put Flutter on this level. Yes, finally, a 100% web-dedicated moment. We have mentioned a lot of advantage of web apps and the really new cool things for progressive web apps. At this stage, you will master TypeScript/JavaScript and will be absolutely comfortable working offline and also with mobile-related features like push notifications. The icing on the cake, in my opinion, is not frameworks, libraries, text editors, or other tools. They are all there just to make your life easier. At least they should. So I prefer to focus on coding architecture, design patterns and good practices, as well as how to test your app. From unit tests to end-to-end tests. I know it might sound crazy. How can I learn 3 different languages at the same time? I'd probably agree with you if we had only Java for Android, Objective-C for iOS, and JavaScript for web. Not because they are bad, but because they are intrinsically different. The first two are statically typed, but JavaScript is dynamic. Objective-C is, in my opinion, particularly cumbersome, and Apple made a clear choice of having hugely long names for the API. Java is also known as verbose, and its massive legacy, due to decades of being the most popular language in the world, make things harder to evolve. On the other hand, Kotlin, Swift, and TypeScript are much closer. They have much more similarities than you might think. Let's have a look at some of them. Don't worry if you don't program, I'm not here to teach you that, but just to present how similar those languages are. If you are an experienced programmer, the level of correspondence between them might surprise you. The first code snippet is a Kotlin code that creates 3 variables. The first is called apples, which is an integer and has been assigned the number 3. For those who don't program, I'm just storing in memory something like the quantity of apples that was in a supposed grocery basket. Apples is not a variable, it's actually a constant, which means that once it's assigned a value, it cannot change anymore. This is achieved by the special word val. The second constant, oranges, receives 5, but notice that we did not define the type. It does not mean that Kotlin is dynamically typed. It means that the compiler, based on the obvious assignment, is able to infer that oranges is a number. In the same way as for apples, it won't allow you to assign values from another type. Actually, again, because of the val, it won't allow you any new assignment because it's a constant. But bear in mind, there are 2 different concepts here. Fruit summary, in its turn, is inferred as a string, and it comes with another 2 new concepts. First, to make the code fit in this little space, the string was split into 2 lines, and to glue the pieces, we use the plus sign. At the end, the string will be considered as a whole, with no line breaks. Second, we want to evaluate inside the string the summatory between apples and oranges, and this $sign followed by curly braces surrounding our math expression is called string interpolation. At the end, it's served as a placeholder for the operation 5 plus 3, which is 8. The final string is, I have 8 pieces of fruit. Easy, right? Let's see in Swift. Look at that, the code is almost the same. It relies on the same concept of constant, but we have to use let instead of val. It also relies on the same concept of type inference. Note that we didn't set the types of oranges in fruit summary. The concatenation works in the same way, and the interpolation has again minimal syntactical difference. / round brackets in place of $sign and curlies. What we have for TypeScript? Again, no major difference. Neither val nor let, but const for constants. Okay, the explicit type for apples was number instead of int. There is no number distinction for TypeScript. But again, the same concepts apply. If you are attentive to details, you notice 2 things. First, there are semicolons at the end of each instruction. This is not mandatory, unless you want to write 2 instructions in the same line, and it's accepted by all of the 3 languages here. Apparently, Kotlin Swift users prefer to avoid them. The second small difference is the backtick embracing the part of the string which contains the interpolation. So interpolation are not evaluated as such inside normal quote strings in TypeScript. To sum up, constants are val, let, or const, respectively in Kotlin, Swift, and TypeScript, but variables are var everywhere. To don't be negligent, I have to say, be careful with let. As we saw in Swift, it defines constants, in TypeScript it defines variables, but with a difference in its scope comparing to var. Kotlin also makes use of let, but to generate a new scope for function returns. That's more advanced concept, so just leave it for now. Let's start with Swift this time. Here we have 1/5. That means a range, a collection or array of numbers starting from 1 up to 5. The for loop will repeat commands inside the curlies for each element in this interval. So the print command will print out on the device's console that string with 2 interpolations. One for the variable index, that assumes the next value from the range each time it runs, another the math expression index times 5. In Kotlin, the for loop has its logical condition closed by parentheses. There is a print command, but println or println adds a trailing line break. Oh, there is no range in TypeScript, so I create one using a combination of array functions. I'm not gonna explain that, but trust me, the constant call range will have the same to give to the for loop. There is an explicit representation of the console, and the log method does the same job. Now let's create an array of arbitrary values. Shopping list is an array of strings. The position 1, accessed via square brackets, was water, but is changed to bottle of water later on. Weirdly, Kotlin has no construction shortcut for array, so instead of simply type brackets, we call a function array_of, but the rest is the same. There is absolutely no change from Swift to TypeScript in this case, except for the const that we covered before. Constants pointing to objects in Swift are not allowed to change the object state. So if we had declared shopping list as constant using let, the bottle of water assignment would fail. You might have noticed that this is 100% valid JavaScript code. There is no TypeScript addition, but because of the type inference, we would not be allowed to change shopping list position 1 to anything other than string. Functions are instructions that you can declare to reuse, calling later. In this case, upper is a function that gets a string, internally called str, and returns whatever it is passed in all caps. In Swift, functions are declared with func instead of fun. The return type is defined with an arrow, and there is a very cool concept of internal and external names for parameters. To don't go too deep for the moment, we use the underscore to skip the external name. In TypeScript, functions are set with a function keyword, but the rest is the same as in Kotlin. Functions can be expressed in many different ways. Here they are called anonymous functions. As you can see, there is no name after the fun keyword, but the whole function instead of its result is assigned to the constant upper. There is no anonymous function in Swift, and in TypeScript there is no new difference, exactly the same as in Kotlin. Kotlin has also functions called lambdas. Lambdas are very succinct expressions surrounded by curly braces. Note that after the equal sign, there is no type declarations for str and no explicit return statement. This unique line result will be assumed as the function return. As lambdas do not declare types, they must rely on explicit type definition of whatever variable is receiving them. So upper is declared as a function that gets a string and returns another string. That's exactly what this string inside round brackets and followed by an arrow and string are doing. Note that in the anonymous function above, upper could have been declared with the same thing between the colon and the equals here. We didn't do that just to don't be redundant. Swift has also lambdas. And what? The function type declarations exactly as in Kotlin. String, arrow, string. But inside, instead of another arrow, we use the statement in. The whole idea is absolutely the same. TypeScript has no lambdas. Instead, there is a handy construct called arrow functions, or to be more precise, fat arrow functions. It has an important particularity. If you are curious, that's regarding the lexical scope of the this keyword, but I'm not going to extend too much on that for now. Lambdas with one single parameter in Kotlin don't need to declare not even the parameter name. Just use it internally. The idea in Swift is extended to more than one parameter, as you can access them through positional names with $sign and a number. In this case, $0. Nothing on this for TypeScript. Finally, Kotlin has one-liner functions. Removing the curlies, the very next expression after the equal sign will be treated as the whole function body, and its result will be the function return. You can achieve the same simplicity with arrow function in TypeScript. Now let's start with TypeScript. Please allow me to don't explain much on that, otherwise this video would take forever. As I said, my focus is to show the correspondences in those languages, not necessarily explain the concepts. In TypeScript, class attributes are ordinary variables with no usage of var, let, or const keywords. Read-only is used to turn variables attributes into constant ones. Methods are like regular functions, but also without function keyword. Constructors are functions exactly called constructor, instead of the same class name as Java programmers would expect. Object self-reference is called this. So this constructor is assigning its admitted arguments, name and number of sites, to the object's internal state. Look how similar it is in Kotlin. Except for the open class at the beginning, as classes in Kotlin are final by default, and also for the usage of val and var to declare constant and variable attributes, all the rest is the same. In Swift, constructors are called initializers and defined using the init keyword. It uses self instead of this. As you can see, all the rest is the same. In TypeScript, there is a shortcut for what was done above. Declaring parameters with read-only, public or private, they are automatically converted to objects attributes. No need for manual assignments. Kotlin has something conceptually similar, although not exactly in the same way. Classes can have a primary constructor, which is a declaration at the class header, with the only intent of declare auto-initialized attributes. Swift has convenience initialized, but with a different idea. I won't take this for now. To inherit from a superclass, use the keyword extends. That's pretty common in many other languages. To reference elements from the superclass, use super. Let's assume that we have created a method called simpleDesc in the superclass. This declaration here will override it for Square instances, but it's still possible to access them internally using super. In Swift, there is a super command, but instead of just super in parentheses to call a parent's constructor, you have to call super.init to call the parent's initializer. simpleDesc will not only override its parent's counterpart, but the override keyword will ensure that you won't accidentally type anything wrong and end up not overriding that. Kotlin goes a bit crazy when it comes to classes. Besides primary and secondary constructor, it also has initialization blocks. Init blocks don't allow parameters but can be handy to group attributes initialization together. Kotlin also requires the override keyword on the method, and the method must be declared using open keyword in the superclass, otherwise it would be treated as final, so no override would be possible. Finally, let's create objects. In Kotlin, just call the class name as it was a function. This will create your instance. Here, Square defines name, number of sides, and side length, and you can read those from S at any time. However, the constant n was explicitly declared of the type namedShape. That's what is known as polymorphic attribution. Although the object is an instance of Square, you cannot access n.sidelength because n is set as namedShape. At the very end, S2 receives n, but as a square. Can you infer what's the type of S2? In Swift, everything is quite the same. The only exception is the exclamation mark, which is a forced unwrapped of optional values. In TypeScript, the absolute unique difference from Kotlin is the operator new to instantiate the object. Well, that leads to the end of the video and also the end of the entire series. I hope you have enjoyed it. I know that learning 3 languages at the same pace can be absolutely mind-blowing, but I hope you have realized that they are not so different. And if you decide to study concept by concept, feature by feature, and look how they are achieved in all of these languages, you might save much time. But if you are asking where you can find content organizing that so particular disposition, I'm happy to say that's exactly what I'm putting together at the moment. I'll be launching soon courses following my mobile polyglot plan, so stay tuned. Follow me on Twitter, YouTube, LinkedIn, and also on Udemy, and I will let you know once it's live. Thanks a lot for accompanying me for so long for this whole journey, and see you soon.